The speaker of today's talk is Dr. Manish Gupta from IIIT-Bangalore. Dr. Manish Gupta is the director of Google Research India and Infosys Foundation Chair Professor at IIIT-Bangalore. Previously, he has led VideoCan, a video technology startup, and the research centers for Xerox and IBM in India. As a senior manager at the IBM TJ Watson Research Center in Yorkton Heights, New York, he led the team developing system software for the Blue Gene supercomputer. IBM was awarded a National Medal of Technology and Innovation for Blue Gene by US President Obama in 2009. Professor Manish holds a PhD in computer science from the University of Illinois at Urbana-Champaign. He has co-authored about 75 papers with more than 7,000 citations in Google Scholar and has been granted 19 US patents. While at IBM, he received 2 Outstanding Technical Achievement Awards, an Outstanding Innovation Award, and the Lou Gertzner Team Award for Client Excellence. Professor Manish is a Fellow of ACM and the Indian National Academy of Engineering, and the recipient of a Distinguished Alumnus Award from IIT Delhi. Welcome, Professor.
Thank you. It's great to be back. So I'll first talk about, I'll give the talk in 2 parts. First talk about the work we have been doing as part of the startup that I co-founded called VideoCan, which is actually continuing. And then I'll talk about, again, some of the work that we are doing at Google Research and opportunities for collaborations. Okay, so we have seen, again, growing use of informational videos. So by informational videos, I mean those videos where the primary purpose is to convey information. There's also a very large class of videos where the primary purpose is entertainment. So I'm distinguishing between, and sometimes the boundary between entertainment and information is fuzzy, but again, I'm making a loose distinction. So if you look at the use of videos that convey information, there's a lot of use happening, growing use happening in various enterprises, apart from, of course, educational institutions. So you find companies using them a lot, for instance, to record their customer events. So often these events are recorded and then those videos are put on YouTube to be used primarily for marketing purposes. There are a lot of marketing videos that are created specially to, again, promote specific products. There's a lot of effort spent by companies in training both their employees. So these are internal, for internal learning purposes, as well as to train customers and partners. So often these are part of different functions within a company. Usually the HR and learning and development function focuses on the learning for your employees, and often there is a different function called sales enablement in companies, which cares about training for customers and partners, because again, and that sales enablement is again has kind of some overlap with the marketing function, because again there the idea is to make your customers and partner more familiar with the products so that you can have greater usage of your products. And growing use in terms of internal communication, right? So many times we would set up now meetings over web conferencing. So certainly, for instance, now that I've joined Google, pretty much by default, anytime you schedule a meeting, there's always a URL that comes up by default, which is setting up that Hangouts video meeting, and there is an option that you can have to record those meetings and then share the recordings with people who have not been around. Now, I would say today, very few of us actually record these meetings and then share those, and I would say this is largely because, I mean, we know if we share those recordings, in most cases, the people that we want to share it with, they will not have the time and patience to go through the entire video. But certainly I've seen, again, I mean, for instance, within Google, I've seen all these various all-hands meetings and so on being done at different levels, and there's something called TGIF, which is held every week, where the CEO comes to one of these cafeterias and kind of often there are certain themes which are getting addressed, and then people ask questions and so on. So there are these meetings which are held very, very frequently, and all of these are recorded, and then the recordings are shared. Now, what happens is when you share again these recordings, the big problem, while a lot of investment goes into producing these videos, there is still a huge issue that usually the intended audience, the people who are supposed to consume these videos, often do not have the time and patience to watch these videos end to end. So we looked at this particular problem and tried to see, I mean, is there something that we could use in terms of, for instance, we took inspiration from textbooks. That just like textbooks convey information, and when you give a textbook to somebody, you don't expect the person to just read the textbook from cover to cover. So when you give a textbook to somebody, the first thing they usually do is they look up the indices which are present in each textbook, right? And the most commonly used index is the table of contents. So you would typically, when you're given a textbook, the first thing you do is you look up the table of contents, see the various topics which are being covered, and then at a given time you may only read the textbook with respect to a single topic. And in addition to things like the table of contents, textbooks also have these indices at the end. There's an index at the end which describes gives you a list of the key concepts that have been touched somewhere in the book, and for each of those concepts it will tell you which page numbers that concept appears in. So we took inspiration and said, look, even videos that convey information ought to come with all these indices, and since they don't already come with these indices, let's apply AI to automatically generate these indices for these videos, and in the process make it easier to consume these videos. So that led to this work again on these AI generated indices. So we generate three kinds of indices: table of contents, phrase cloud, and a full transcript, a full searchable transcript. So let me just show them one by one. So the table of contents essentially summarizes, similar to a textbook, the key topics which are covered, and we show you a preview. Even before you start playing the video, we overlay the thumbnail of the video with that list of topics, so that even before you start playing the video, you can quickly preview the topics and then jump straight to the topic which is of interest to you. And in addition, you can also quickly take a look at how long a particular topic lasts, because these are all also marked with the timestamp. And you can enable analytics by topics watched, right? So as people start watching these videos, you can now, in some sense, identify which topics are of greatest interest to the viewers. So the second index that we produce is again analogous to that index at the end of the textbook, which is called the phrase cloud. And this again identifies the important phrases. And when you click on any of those phrases, it shows you all the occurrences of that phrase. It gives you the context of where it appeared, and then lets you again jump straight to those points in the video where that phrase is being mentioned. And finally, we also provide a complete transcript of the video, and we provide a search capability over that transcript, so that when you search for any arbitrary word, it shows you where all somebody has spoken that word in that video, again gives you the context and lets you jump straight to those points. So just very quickly, so in what manner have we applied AI to generate these indices? And again, what are some of the open problems? So first, let me describe how we do phrase cloud generation, where we only start with the audio part of the video, and over that we apply the usual automatic speech recognition techniques. At VideoCan, we had built this we had utilized this deep speech to architecture, which was released by Baidu in open source, and we build up our model based on that. So that gives you the raw transcript. Now, often the raw transcript, I mean, it's not very easy to read. So then we apply automatic punctuation to that raw transcript to make it a bit easier to read. So the punctuation is applied using, again, an LSTM based model. And now from this transcript, we try to extract the keywords. And this, I mean, sounds deceptively simple that, okay, you are identifying these keywords. It actually took us roughly 2 years of work at VideoCan to get it to a stage where when these keywords appeared, people said, yes, they make sense. So in fact, there are now some other products, including from the likes of Microsoft, which do that, and the VideoCan customers have told us that the kind of keywords that you provide are far more meaningful than the kind of keywords that they see in some standard kind of other products, which are also beginning to provide this capability. So there, again, some of the techniques that we have used, they include things like, we started with the traditional techniques of the statistical measures like TF-IDF, right, term frequency, inverse document frequency, and so on, and text rank, and so on, to try and automatically identify which keywords looked important. And then we deployed a whole bunch of additional methods, which includes things like, again, word and phrase embeddings to try and identify the phrases which were related to each other. And then we started doing clustering of these phrases to see which. So through this clustering, we are able to automatically identify which are the dominant themes of the video. Because typically the dominant themes would have many phrases which would be related to each other. So they would be kind of connected, closely connected in this graph that you get out of those embeddings, and you would be able to see those dominant themes, and then often also identify adjacent themes of the video, and then often concepts that are just by themselves, not connected to any other. These are, we think of them more as an outlier. So then we have an algorithm that tries to pick up representative words from these clusters to try and at least identify the dominant themes of the video, but also kind of have some diversity, not only pick up phrases from the dominant themes, so have some kind of a diversity. And then the other thing that we utilize is also available kind of forms of external knowledge, like entries in Wikipedia and so on. Because, I mean, if you have an entry in Wikipedia, there's a good chance this phrase is important. So we utilize all of those to finally come up with those key phrases for phrase cloud generation. Table of contents is a fairly hard problem. So I would say that at this point, we have been reasonably happy with the quality of phrase cloud that we get for most videos, but we make them also editable. So we do provide, again, a tool through which any of these indices could be edited. And generally we find is when there's a human who has to edit, now we find very little editing being done by that human of the phrase cloud because the quality looks reasonable. Table of contents is a fairly hard problem. So now it works reasonably well when you have slide-based videos, when you have either slide-based videos or whatever, some video where there is significant text showing up, and that text is fairly significant in terms of the overall content. So to show you how that slide-based video, the automatic table of contents generation works for slide-based videos, again we start with, so we look at this video part and we apply a fully convolutional neural network to first identify the keyframes. And keyframes identification is important because often, I mean, so for instance, as this video is being recorded, the point at which I transitioned to this slide would be identified as a keyframe, because now subsequent frames also have this text, but those are not the points where the transition is happening, right? So you have to identify the keyframes which correspond to these important transition points. Then you have to also identify the bounding box and so on, because often, especially as we have handled different kinds of conference presentations or webinars and so on, there are often different styles. I mean, you may have sometimes the majority of the screen, which is showing the slide, sometimes the majority of the video frame is showing the speaker, and this material is kind of in some corner, or it could be the other way around. It could be most of the video frame shows the slide and the speaker is in some corner, or there could be like different regions and so on. So there are a lot of variations which are then handled by this region-based approach, where you're able to identify then the region of interest and then do basically things like OCR and so on, right? Optical character recognition to recover the text. Now, even the text that you recover, often is noisy text. So often there are mistakes, and often it is non-trivial to figure out from that text what is the most important kind of, let's say you're trying to, from a slide, you're trying to figure out which is the title of that slide. So and if you just kind of go by some rules, that won't work very well. If you just go by the rule, oh, the title will be on the top, and or whatever, the title will always be the largest font and so on, that doesn't work. Because again, often there might be a logo that you may have which is larger than whatever the typical text, and likewise the titles. I mean, different people with different style have different styles, and there may be kind of these titles may show up in different points and so on. So again, it's often non-trivial. But the more interesting cases are when you don't even have slides in the video, right? How do you then infer this table of contents? So one piece of work that has been done in VideoKen has been, again, I mean, so the first approach that we tried was, again, from first principles. As you get the transcript of the entire video, can you kind of do some kind of a topic modeling and automatically identify those points at which there is this concept drift happening? There is kind of the main concepts that you're covering is kind of changing. And so we tried, so that would be in some sense the most general approach. We tried that multiple times, and we then even tried to have it in some sense be aided by things like typical transition points, because often people would say, okay, next I'm going to talk about this, or things like audio pauses, because often there is the speaker would take a pause before they move on to a different topic and so on. But we kind of quite miserably failed in most of these attempts. So that is still an open problem. I mean, it would be a fairly interesting research problem. Given, let's say, an arbitrary lecture, can you automatically identify the points at which, again, there is some substantial change happening, right, in the topic? And of course, common sense tells us that yes, there will be other cues to aid that, with things like pauses as well as. So the trouble with a lot of these phrases is that different people will use different phrases. I've seen many different speakers. Somebody would say, okay, next I'm going to talk about this, or somebody else would have some other way of saying, okay, this is what I'm going to talk about next, and so on. So in fact, we kind of failed to adequately handle most of these. So the general case. Then what we did, the approach that we took was to start doing it for special cases. Just like we had this whole kind of, again, largely deep learning based framework for the special case when you have slides, we again built a similar framework for the special case of things like interviews. And that can be extended to things like panels and so on. So interviews is again a fairly common class of videos, because often you find many shows, TV shows and so on, right, would be basically interviews. So for interviews, we just then applied the basic human understanding that whenever there's a change in the speaker, and if you can automatically identify who's the interviewer and who's the person being interviewed, the point at which there is a change from the change of speaker from the interviewer to the person being interviewed, that's a logical point for a table of contents. And the summary of what the interviewer asked could be a good table of contents topic. So then basically our team implemented that particular version, and again, the quality of that version is still needs to be improved. So there are still kind of ways to go. But this is how we, again, using AI, we provide this automatically generate the table of contents. So VideoCan is getting used again. We actually originally started as a learning platform, but in addition to the learning platform, then we started focusing on this video indexing capability that could be provided not just for learning videos, but as well as other broader class of videos. So at this point, yeah, there are close to 30 active customers using this particular video indexing. I'll just provide maybe one brief case study. So we first, on our own, we did this indexing of all the talk recordings from the NeurIPS 2018 conference, and we shared it with the conference organizers. So they were very happy, and they kind of, in fact, changed all of the links from their conference webpage to start pointing to the VideoCan index versions of these talks. And we started to see fairly good usage. So I just realized I should have added a slide. So one of the things we are able to do is when you have all these people viewing these videos, we instrument all of these views, again in an anonymized manner, and we are able to track kind of how many views every minute of the video, how many views is every minute of the video receiving. And as we have tracked these views, we have discovered, right, what may be some of the dark secrets of the video, whatever industry and so on, that especially when it comes to informational videos, usually very few people, watch kind of the complete part of the video, the complete video. And usually there are very, very sharp drop-offs, because often you'll see a video on YouTube and you'll see, oh, this has 40,000 views, some videos have million views and so on. If you track the typical usage behavior and you see, okay, how many people actually reached the first minute of the video, you will find a very, very sharp drop-off. Usually you'll find probably less than 5% of the people will even reach the first minute of the video. And when you look at the second minute of the video, often it is less than 1% of the users actually reach the second minute of the video, and so on. So, and then there's a long tail. So there are some users, yes, who are very interested and would watch the complete thing. So the usual video viewing pattern, when you plot the number of views on the y-axis and x-axis is the time, so the usual pattern is something like this. There's a very sharp decay. So what we have seen, and again, sorry, I should have added those slides, is we often see these very interesting then mini peaks. So because people kind of are not interested in the later parts, but then they say, okay, this topic is of interest later. Normally they would have not bothered getting to that topic, but since they now see it from that table of contents, they directly jump to that particular topic. So you start to see, you still have the macro pattern is still similar, that yes, the early parts of the video see more views than the later parts, but you now start to see over that kind of these mini peaks based on the topics that are of interest. So the other thing that we track is we also then track the total area under the curve. So the total area under the curve will give you the aggregate watch time over all the viewers. So the increase in the watch time, in the aggregate watch time, is an important metric for us, because we want to see, as a result of this, how many people. So now our team is trying to do certain A/B testing and so on for that, which is the right way to measure. In early stages, when we didn't have as much traffic, we were simply kind of making a simplified assumption that if the original kind of declining trend were to continue asymptotically, what would be the area under the curve under that hypothetical condition? So we assume that would have been the case if these indices were not provided, and what is the area under the curve with that? So if we make that simplified assumption, which may not be valid, we saw, at least for NeurIPS, for tutorials, which were like typically 2-hour presentations, the aggregate watch time going up by typically 7 to 9x. For even the 1-hour keynotes, we were finding the aggregate time going up 6 to 8x. And for shorter presentations, which were like individual papers and so on, which would often be 15 minutes, the aggregate watch time still going up by about 2.5 to 4x. We did similar analysis for ACM webinars, which are typically 1 hour in length. There we were finding for ACM webinars the aggregate watch time going up on an average by about 3.6 times. So this again, the NeurIPS Foundation folks were quite happy with what they saw. So this in fact led to then our engagements with then other conferences like ICLR. So these are some of the top machine learning conferences. International Conference on Learning Representation on Machine Learning, and NeurIPS and so on. One outcome of that is, as a personal thing, for instance, they gave me a complimentary registration to any of these conferences. And NeurIPS, for anybody who has tracked NeurIPS, it's now an achievement to even get a paid registration at NeurIPS. This person, so I jumped on that and I told him, yes, please do sign me up for NeurIPS 2019. And I got that automated email saying you have been registered and so on. And then this person, Lee Campbell, said, you are the first person registered. So I thought I should put that on my resume, because that's, I think, my biggest achievement in AI, to be the first registered attendee of NeurIPS 2019. So anyways, so this was my achievement in the world of AI, that I got free registration, and I was the first registered attendee of this upcoming NeurIPS. This was some of the dashboard data. So we found very heavy use of these table of contents clicks and phrase cloud and so on, and that. Okay, so I'll stop with this part of the presentation. Again, happy to take any questions, comments if you have.
When does the model happen?
Yeah, so that's an interesting question, because so by the way, for this other conference, ICML, we were powering also their video search. But in this case, video search could give you more things like best paper award. If you enter the term best paper award, it will look for, okay, where is best paper award appearing in the things like transcript, phrase cloud, and table of contents. And when it is showing up in the table of contents, so it will show you, it will show you that entry and let you jump straight to the point in the video where, let's say, the best paper award is being presented. So when these events and so on, right, are appearing in the form of visible text, which becomes an entry in a table of content and phrase cloud, yes, we are able to do that. There are companies, so I mean, there was a company called Barzo, I know, and so many companies have been working on other solutions where based on understanding of objects and activities, right? So often people in the computer vision refer to this as detecting nouns and verbs, right? So nouns are the objects, verbs are those activities. So if we can identify those interesting objects and activities, you can start tagging these videos automatically and therefore later allow you to search. So yes, I mean, that work is happening. There's a fairly active area. In terms of, I think, commercial products, it's still, I think, commercial products are still not as sophisticated when it comes to those capabilities right now. Yeah.
Two questions. First one, do you do any kind of video summarization as well? The table of contents is fine, but some kind of a text or something which tells what to expect.
Yeah, so good question. So in fact, text summarization is one of the problems that in fact, some of our customers have posed, and I've been running some research electives here with some of the students. So there was some work done last semester, but there again what we observed, I mean, it requires more work than typically what a single semester's class project allows, because if you allow traditional techniques for text summarization to the transcript, what we found was you don't get very good results. I mean, these have been applied a lot to news. So often, I mean, when we applied them to the video transcripts, the results were not particularly good. So our belief is, one is we need some specific additional techniques. Yeah, so that's a good point. So in fact, that cross video analysis is important for search also. But yes, so the VideoKin team has been developing this notion of what they call video lake, which would be like for a collection of videos, can you present again the various indices in an interesting manner, as well as support things like search and
good idea to publish along with the video its table of contents and worked out by, for example, your system. Could help choosing which video to look at.
Yeah, I would say so. I mean, so we would certainly like to see these kinds of systems being used, and it is for that reason that even before you start playing the video, we overlay the thumbnail of these videos with these. Too early to say. I mean, we have certainly been advocating this particular direction, but yeah, it depends on how.
It's up to the user now to look for the appropriate AI to.
Yes, it is up to, again, the people who make this content, who create this content and make this available, to kind of use services like these, and then for the end users to demand from the content creators. Yeah.
So as far as looking at this, it's interesting. So I guess the holy grail would be to have it across languages.
Yeah.
So if somebody's giving a talk in Japanese or something, or in Kannada,
yeah,
translated in English or some other language,
yeah,
probably be eventually what is supposed to.
That's right. Yeah. And ideally even kind of create a new video which is in the whatever the appropriate person's voice and so on.
Right, but I mean, how different would that be from his subtitling? Because there is that whole thing that actually exists in India. This guy at IIM-Ahmedabad who actually does this wonderful work, which work with recognized, where it's called subtitling based literacy, where they take all these Bollywood songs and all of that and they can put it down on the screen.
Yeah.
So that people know, they're able to sort of connect.
Sure.
So look at how these look graphically, and then there's this literacy just with enormous effect.
Sure.
So how different would that be from subtitling?
Yeah. So I think one good step would be subtitling, that you are able to first create the subtitles and so on, right, in the at least the original language of the video. The other would be you allow that to be translated into whatever the different languages, and you should have options that depending on your preferred language, you are able to see subtitles in your specific language. A still further thing could be if you also wanted in that language that video to be dubbed. And further step could be if you wanted that dubbed, whatever, in a specific personality, right? Let's say you want whatever, you want to hear the lessons in Amitabh Bachchan's voice, maybe that makes the video more, whatever, make the lecture more of greater interest to students and so on, right? So there are all those.
The central idea, am I correct? The central idea is to speech to text. Audio part of the video is of paramount importance in this approach. The other part is not terribly important, but it's important only to the extent of seeing if there is some text material.
Right.
And then you play with the text.
Right.
Are we using something of this approach?
No, absolutely. So because, I mean,
a lot of geometrical things.
Yes, because there could be a lot of other important signals in the video, which could be whatever the point where somebody is emphasizing, or there are gestures through which you are conveying something, the importance of something. So ideally, you would like to take advantage of all of those other signals. Right. So in surgery, yes, ideally you should kind of be able to automatically identify that active. Okay, so any other questions or comments? Yeah. Yeah, so ASR errors, yes, I mean, often, especially when you see people, speakers in the non-native English, speaking with a non-native English accent, we see a lot of ASR errors. So there are two comments I would make. One is, what we have generally seen is, if let's say you see a certain percentage of word errors in ASR, in the transcript, the typically error rate in phrase cloud is usually much lower, because what happens is, while you could get a lot of the words incorrectly, when you're trying to identify the important words, important phrases, usually you make fewer mistakes when it comes to those more important words. So that is one saving grace, where often even when you have significant errors in the transcript, in the phrase cloud we see fewer errors. The other part is, we had done some work where you can take advantage of the text that you are recognizing, because sometimes, let's say, the stuff that I'm talking about, maybe I also have a slide describing some of those concepts. So one example is, let's say, matrices. Often the way we might pronounce matrices, sometimes the speech recognizer confuses that for mattresses, the ones that you sleep on. But again, if matrices is also appearing on the slide, then you could use that information to kind of more heavily weigh those probabilities. So there's been a little bit of that kind of a work done by the VideoCan team on can you take advantage of some of the visual information to reduce speech errors. Another technique that we discussed, don't believe it's been implemented yet, was to do some kind of a post-analysis. I mean, once the transcript has been generated, can you just do kind of an analysis of that text? And in many cases, from the context, you will be able to make out certain words, right? Because what happens is, when you're creating the transcript, normally you're kind of only you don't know what is coming later. You only do the detection based on what you have already seen so far. So now, once you have the information about also what is coming later, it may help you do certain corrections when you have the complete context. So those are at least techniques we have thought about. Yeah. Yeah.
The video experience, like with speech listening experience, is typically a linear experience. Right? So what you are really doing is to convert the linearity into a non-linear.
That's right.
So taking cue from typically what you can call as a video browsing or video navigation, have you looked at something like hypertexting, which allows you to walk through the video in a very non-linear manner, as if you create multiple threads which somebody can follow?
Yes.
Hypertext is more Macintosh hypertext.
Yeah. No, absolutely. So actually, in our learning platform, we kind of try to do that also through other ways. We also let you tag videos with your notes, and we try to have all of these mechanisms available that you can navigate the video through any of these kind of by text, by table of contents, and so on. And the other thing that we have been thinking about is, how do you then allow these videos to be navigated when you have a collection of videos, not just a single video. Yes, so we've tried to do. So an interesting observation that somebody once made to me was that for us, when we are conveying information, usually it is much faster if we speak compared to when we usually when we type or something, right? Or when, so I mean, if I'm providing input to the computer, speech is a much more natural way for me to convey that information. But if I'm getting information back from the computer, visual is far more is far more appealing and faster than speech, because speech tends to be fairly sequential in nature. So whenever you have these kinds of videos or speech-based things and so on, right, which are inherently sequential, if you are visually able to provide these cues of what are the topics and where to jump and so on, yeah, so he was saying, yes, this should benefit people, because while taking information back from the computer, speech and so on are not particularly appealing. Any other? Yeah.
When you're feeding the entire subdomain of Goa through a CNN, so are you assuming there are 60 frames per second is recorded, the camera speed is 50 frames per second, so there will be a lot of frames that you supply to the CNN. So are you, did you employ any method to keep certain frames?
Yes. So that's the keyframe detection part, where you're first of all those frames, first you're trying to identify which of those frames are keyframes, and then focus more on those keyframes. Yeah. Okay, so let me then jump to the second part of the talk related to more of my current role. So again, a few weeks ago, Google announced the creation of the first research lab in India. And again, I mean, they said they didn't have very good explanation for why it didn't exist in India earlier. So Google research labs exist in several other parts. So in the US, there are major labs. So the largest one is in Mountain View. There's also a fairly significant sized lab in Seattle and one in New York. Europe has relatively smaller labs. So they have one in Zurich, one in Berlin, one in London. So the London one I'm referring to as different from DeepMind. So DeepMind is is like almost like a separate company. Again, part of that same group of companies. So there are a bunch of labs. There's also one in China, and they recently opened one in Accra in Ghana. So Bangalore, there's one in Israel, by the way, Tel Aviv. So the one in India is the latest of the research labs, and the overall charter for Google Research. Again, Google Research itself is a kind of a relatively young organization, because I mean, if you look at early years of Google, research and engineering were very closely integrated. And traditionally, if you go back to, let's say, the time when Google introduced MapReduce and so on, MapReduce was one of those exceptions when they actually published kind of what they were doing. Typically, Google in its early, at least the first 10 to 15 years, Google people rarely published anything in the public domain, right, in terms of what they were doing. But that culture then started changing. So now there's a lot of emphasis on publications and on creating frameworks, platforms which are released in open source. So now if you look at, in particular, some of the top AI conferences, if you look at NeurIPS, ICML, and so on, you will find like tons of papers. Often you might find a top AI conference where over 5% of the papers being presented at the entire conference, there is some Google affiliation of the authors. So there is a lot of emphasis now on publications and also on building infrastructure to allow research, and there's a lot of desire to allow more and more people, more and more practitioners to be able to build these kinds of machine learning based solutions. For example, is TensorFlow, but also work being done on things like AutoML, right? How to allow software developers who may not be machine learning experts to build these machine learning models automatically. So of course, like any corporate research lab, there's a lot of emphasis on collaborating with product teams to influence product features and directions and so on. And again, some of these classic examples are things like Google Translate, Google Photos. They came entirely out of work that was done at Google Research. And of course, I mean, things like search and ads, where again, there has been a lot of work in trying to improve the quality of those. And the other objective is to conduct research in new areas where Google doesn't necessarily have a business today. So these include things like healthcare, robotics, and so on. So this is, again, I picked up some of these slides from Jeff Dean. So Jeff Dean, again, talks about how US National Academy of Engineering. Okay, so by the way, one very key item which kind of I kind of resonate with a lot because, again, I've had a similar philosophy, is to really tackle very ambitious project and aim for impact. So again, there is that very kind of ingrained thinking within Google, which they refer to as this 10x thinking, that when you are aiming for whatever, some solution and so on, don't just aim for something which is whatever 30% better, 40% better, aim for something which is 10x better. So even if you end up not producing something which is 10x better, even if you're only whatever 3x better, it's a whole lot better than aiming for that whatever 20-30% improvement and then being happy, oh, you got 50% improvement instead of the original 30% that you were aiming for. So tackle ambitious problems. And so one way in which Jeff Dean would benchmark how are we doing at Google Research is when you look at some of the grand challenges that have been in some sense articulated by reputed organizations like US National Academy of Engineering. So in 2008, they published this list of grand engineering challenges for the next century. So they said these are some of the biggest challenges that our scientists and engineers need to work on for the next century. So this is a pretty comprehensive list of grand challenges that US National Academy of Engineering came up with. And this is, again, the ones in red are things where there is actually some effort at Google Research on actually applying many of these techniques, from, in particular, deep learning to many of these grand challenges, right? So that's kind of one indication that, yes, we are taking on some of these big challenges. So I'll just, instead of taking you through the entire presentation, I'll just cover one, which is of particular interest to me. And we are very much planning on having a key focus on this area at the India Lab, which is to advance health informatics, right? So basically transform healthcare. So one particular work that has been done by this team in several countries, including India, is work on diabetic retinopathy, which is one of the major causes of blindness. So there are worldwide, there are over 400 million people who are affected by diabetes, and pretty much most of these people who have the problem of diabetes, they are at a risk of diabetic retinopathy, which can potentially cause blindness. And so what happens is, as in many healthcare conditions, regular screening is the key, right? So prevention is better than cure, right, is the very common saying. So if you can identify these problems beforehand, you can have much better outcomes. So while screening is the way to go, the problem, especially in the context of a country like ours, is that we have a severe shortage of eye doctors who can do the screening. So what ends up happening in India, and this is like a queue outside, I think this is Shankar Netralay, one of the partners that Google has been working with. And what happens with such shortage of doctors is that you end up with the situation that 45% of the patients you find are suffering vision loss before they are diagnosed with this condition. So, and the way it is diagnosed is, again, when the image is taken of the region, that retinal fundus image, essentially the physician is analyzing and looking for these some hemorrhages, signs of hemorrhage, which indicate that yes, there's a good chance this is diabetic retinopathy. So then what the Google research team did was they basically built again a deep neural network to analyze these images. This was essentially an extension of the algorithm that was used based on this incept architecture that got used for photos, the Google Photos product, to automatically classify photos. Is it a cat or a dog? So while is it a cat or a dog looks like a very frivolous application, now when you start applying the same technology, allows you to be able to then automatically identify these cases. And so we would basically apply this to do classification not only of these different, so you would assign a 5-point scale of whether there is no diabetic retinopathy, mild case, moderate, severe, or really, really severe. So this is a 5-point scale. But in addition, you would also identify, okay, do the classification, is this a good quality image, is this a left or the right eye, field of view, and so on. So then this team basically went and published this work. So we wanted to make sure that the results, it's not just we are getting excited as AI researchers, the results are actually medically kind of rigorous. So the team went and published this work in the Journal of the American Medical Association, which you may kind of recognize is one of the leading journals. They did a comparison of, again, what the algorithm was producing with what the ophthalmologists were doing, and they were getting now better results, better accuracy than some of these ophthalmologists. So, I mean, in 2016, the algorithm was roughly on par with general ophthalmologists. In 2017, it achieved parity with some of the specialists, retinal specialists, ophthalmologists, and obtaining fairly good results. Now we are in the process of trying to roll this out.
Pure image analysis without correlating it with health conditions like that.
Yeah.
So it's just
Purely. Yeah. And now the team is trying to see, can you do, again, further analysis, can you predict cardiovascular risk and so on with that. So just very briefly, what we are, again, when we look at the India chapter, we are looking at, so the India lab, we are looking at, again, having work both to advance fundamental research, especially in these areas that intersect with AI. So natural language processing, computational social science, explainability, machine learning, fairness, all kinds of issues that are fundamental to today's machine learning algorithms. So we are planning on working on some of those theoretical advances, as well as applications of machine learning to problems of interest. And here again, the goal will be to help tackle some of the big problems that we face, again, both as a country, as an industry, and the world at large. So some of the areas that we are thinking about focusing on are, in particular, healthcare, and we are also beginning to work with, for instance, NGOs and so on to identify problems related to agriculture, education, and so on. And of course, we'll also work with Google products and services. A special initiative that's been already called out for. So this began initially as part of this. So Google has this culture of letting employees work for 20% of their time on any problem of interest to them, right? Not mandated by the company or management and so on. So out of this actually came a number of projects where people started, I mean, they already had that AI expertise. So in 20% of their time, they will start working on some social problem that was of interest to them. So this led to a number of such interesting pieces of work where AI was being applied for social good, usually by employees in the 20% of their time. So now there's an effort within Google Research to, in some sense, make it a bit more formal. It reminds me of, I remember when Professor Sujit was giving his Samvaad-Talk, right? He was talking about socially useful, productive work, that every faculty should be thinking about, okay, with my research, right, where can I apply it to some socially useful kind of a cause and so on. So as a number of researchers started coming up with these kind of solutions, now there is a effort to try and formalize kind of support for these kinds of initiatives. So in fact, along with me, the other person who has been named is Professor Milind Tambe. So at Google, we have this notion of also joint appointments with faculty. So Milind is a professor at Harvard University. He recently moved from USC to Harvard, but he has a 20% appointment with Google Research, and he will be spending that 20% of his time at the India lab, primarily driving this AI for social good initiative, where again we are planning to pick up problems, especially from things like public health, but also, I mean, we are reaching out to NGOs and then trying to identify the themes that we can pick up for pursuing projects in that area. So the other thing which we are increasingly recognizing is that as ML matures, because when we look at the overall maturity of ML, today you would say it is primarily machine learning is being deployed, right, by usually either the innovators or the early adopters, right? So there is the usual adoption curve, right, that any technology initially gets adopted first by the innovators, then there are some kind of forward-looking organizations, the early adopters, and then comes the vast majority and then the laggards and so on. So ML is still in its infancy, right, when it comes to adoption. And the point that kind of Google researchers are recognizing is that as you get to the more, as it gains maturity, we are recognizing so many other issues that need to be dealt with before you're able to really deploy those solutions in the real world, right? So there are a lot of issues with data privacy that need to be dealt with. There are a lot of issues with fairness. And fairness is, in fact, right now of a lot of concern to us. So, I mean, Google has now, in fact, come out with a formal kind of a list of AI principles that have been written up, some 7 AI principles, and we are saying that all AI solutions should pay attention to these kind of principles. And Google has committed that, yes, we will abide by these principles as we develop these solutions. And one in particular, which is of a great deal of concern and where we do expect to have some significant research here at our lab, is on fairness, because increasingly, as you begin to deploy these machine learning solutions in situations where you're affecting human lives, right? And already you're seeing so many startups working with HR organizations for screening candidates, right, for jobs. So a lot of job selection today already, there are startups providing solutions that apply AI to help you shortlist candidates, and it is well known. So there have been several studies which show so many biases that creep in, because if you are building these AI-based solutions based on what humans had done, often the humans which the machine is learning from themselves have been biased, right? So there are numerous studies which show, for instance, on CVs, that if you change the name from male to female, suddenly your chances of getting selected or shortlisted go down dramatically. And if you change it back to a male, yes, or the other way around. If you change from a female name to a male name, your chances go up. And likewise, there are sometimes age-related biases, sometimes there are kind of race-related biases and so on, right, that affect these kinds of decisions. Likewise, in loan processing, right, increasingly you're beginning to see startups which will help you make these financial decisions, which will have financial organizations make these decisions about whether or not to award loan. And you might know that the whole, almost this field was triggered, in fact, by the deployment of this solution in the US for looking at payroll applications of that several courts in the US had started utilizing this piece of software. And then there was a report by this organization called ProPublica, which pointed out there was a lot of bias inherent in that software against blacks in particular. So blacks, there was a far higher kind of a false positive rate when it came to identifying blacks, and likewise a far lower true positive rate when it came to identifying whites. So these things are of a lot of interest. Ultimately, things like explainability, because in several contexts, explainability of the solution becomes very important, especially healthcare, security, and so on. So again, these are early thoughts in terms of what we plan to do at the plan to pursue at the Google India lab. So based on already some of the discussions I've had with folks, these are things that I have picked up as interesting areas in which we should be working with Google products. So Google Assistant in particular, right? So natural evolution of Google search is you might call the assistant, right? Which is able to have a two-way dialogue with you, right? Whereas search is more of a one-way. You ask Google a question and Google comes back with the answer. So there's the Google Assistant, which is now being shipped not only on Android phones, but also these feature phones from Reliance Jio called Jio phones. And with this, today I learned that they have over 20 million daily active users of Assistant. And today, Google Assistant supports multiple Indian languages. So these are the Hindi, Bengali, Kannada is also there on that list. So these are all the languages that are officially supported by Assistant. But again, I mean, there was that question of ASR errors and so on. No guarantees about the accuracy, right, of what you're getting. So a lot of these language models were built in more like idealized kind of settings. And when there are mere mortals speaking in that language and all kinds of dialects, using all kinds of dialects and accents and so on, the actual accuracy on many of these is quite low. The other thing that, again, is not surprising that you're recognizing is the need to build multilingual models. Because often you don't want, okay, is this a model for English or Hindi? Often we mix, right? So we need a model that can understand a combination of Hindi and English, right? So again, I mean, one attempt that many researchers have made is to build these Hinglish models, which will understand both Hindi and English. But ultimately, I mean, again, the holy grail there is to build a single model that can understand any arbitrary, whatever combination of languages being used, even in the same sentence. So people do a lot of, I mean, especially in India, we do a lot of what is known as code mixing or code switching, right? That we move from one language to another in the same sentence. But the other interesting issue that these people, the product managers, told me was many of these, especially the geophone users, these are first-time users of any real device. This is their first time on the internet. So it goes beyond just kind of interacting with them effectively. What do you do to make this a useful device for them? Can you kind of engage them with things that will help them learn at least how to use the device as a first step, and then how to take advantage of the internet in a more meaningful manner, right? So how do you give the right recommendations? So there's also been work done at Google on this app, for instance, called Bolo, that has been developed to teach people different languages. So there's a lot of, again, interesting issues here, both I would say user experience issues and so on, as well as technology, AI kind of technology here. The other thing, interesting thing that happened is Google came out with a product called Google Pay, and then there was the India-based team which developed a product called Google Tez. And what they discovered was that Tez had more active users than the rest of Google Pay in the other parts of the world combined. So now the center of activity in Google Pay itself has shifted to this unit that works on things like Tez and so on. So this is within Google, there's this business group called Next Billion Users Group, which is really looking at, okay, how do we cater to the next billion users of the internet who may come from, again, I mean, for instance, these people who are getting onto the internet through maybe even a feature phone and so on. So again, given the strong presence of this business in India, we have been again engaging with this group, and there are again a whole lot of issues that need to be dealt with. Things like fraud detection, user modeling, recommendations, and so on. Then likewise, we plan to have work on transforming healthcare with a focus on preventive healthcare and wellness. This is maybe the last thing that I'll talk about. This is something which I've been thinking about a lot, about kind of the future world of software development. So already what we are seeing signs of is within Google research and beyond Google research, what we are seeing is a lot of the problems that have been traditionally solved in a certain manner. They are now being solved more effectively by applying machine learning. So even things like, some of these traditional scientific problems like protein folding, some of the most recent results in this protein folding competition. In fact, I used to work on some of these high performance computing, all these simulation based methods and so on. And what you are right now finding is that if you kind of also start to employ machine learning, you start coming up with more effective solutions. I also have some concerns with that approach because ultimately I believe you do need real scientific models of how things are working. But with this clear shift, which is anyways happening, that many of the traditional problems are being better solved by letting the machine learn the solution. And likewise, if you look at most industries, most companies today are thinking about how do I transform my business using AI, right? And then transforming that business using AI means you're deploying some of these machine learned kind of solutions, right, in your company. Interestingly, we are also seeing, traditional product companies. So companies like Microsoft. Again, this was a speculative discussion. When I was at KDD, one of the Microsoft leaders in their development group was talking to Professor Ravindran. He said, "Oh, Ravi, I hear you have this expertise in reinforcement learning. I want to brainstorm with you because we are thinking about replacing a particular product that we have for certain control plane optimizations in the network, millions of lines of code with essentially a reinforcement learning based approach, where their belief is they will get to a much simpler code, which is likely to perform much better than the complex multi-million lines of code that they have. So there are all those, with all this move towards machine learned solutions being deployed, what I'm proposing is that we have an effort at our lab on software engineering for that world. So and I'll just like to distinguish here. There's also today a lot of work being done on applying ML for software engineering. So I'm not talking about applying ML for program analysis, applying ML for software engineering. I'm talking about the reverse. Given that you're anyway moving to this world of ML, and again, the industry is referring to that as software 2.0, right? Where instead of software being written the traditional way with these algorithms that we learned in our undergraduate and grad courses, instead of using those algorithms, now you're no longer using those traditional algorithms. You are presenting machines with data and then letting the machine automatically come up with the machine learned approach to solving those problems. So in that world of software 2.0, how do you do effective engineering? Because one of the problems that we have seen is already at this whole testing end, because while in the traditional world, there are so many well-developed methods to either try and verify certain properties of the software, or if you can't do verification, at least do reasonably exhaustive testing of that piece of software, where you have all these formal metrics of code coverage and so on. If you look at the corresponding analog for the machine learning world, those are still in their infancy, because typically, even when machine learning solutions work extremely well, they usually work very well on data set which is very similar to the data that you trained on. The moment you change the data slightly, often you have very serious degradation in the effectiveness of the solution. So how do you do better calibration, better estimation of how well will this work, this solution work, right, on a broader set of inputs? Can you verify certain properties and so on, right? And generally make the software more robust. Again, I mean, there have been techniques like all this generative adversarial networks and so on, right, to make these machines at least robust to adversarial attacks and so on, but a lot more needs to be done. So my view is that there is going to be a huge set of challenges as these software written in the 2.0 style begins to be deployed in the real world. There are going to be huge set of software engineering, the traditional software engineering challenges to be dealt with. Not just, I mean, initially we are thinking about, because this is a huge area, initially maybe on test and verification, but also on things like other stages of the software development lifecycle, like design and development. Because I mean, design, you may want to offer a design tool that helps you explore these choices, which aspects to solve using traditional algorithms and which aspects to solve using machine learning. And can you, in the same piece of code, can you employ a hybrid of the two approaches? So there has been some interesting work actually done already at Google. There's a where you make certain variables as kind of predicted variables and try to machine learn the values of those variables, and then offer development tools. So already, yes, there is work at Google, for instance, on AutoML framework that will allow a developer not familiar with all of the nitty-gritties of machine learning expertise to build these models more automatically. But as you begin to worry about issues like data privacy, fairness, explainability, and so on, can you provide additional support at the tool and framework level to allow you to build a model that has maybe the right kind of properties? Because in certain cases, you may not care about explainability. So you may say, okay, build me a model and I don't care about explainability. Or you may say, oh, help me build a model which also has good explainability properties. So how do you kind of provide those kinds of tools that help you achieve that? So again, these are some of the areas that we are thinking about that we want to address. And again, one of my, goals is to have at least something which is distinctive about the India lab, which is different from the rest of Google research. So this is one particular idea. I mean, again, I mean, as we hire real people and real researchers, our mission and agenda will evolve, but this is kind of one kind of stake in the ground that I've put in terms of potentially something maybe unique agenda that we try and drive. Yeah, you had a question? Yes. So that's a good question. So yes. So you may have heard about efforts like TPU, tensor processing units, right? So what many people have observed is that when most of the software, let's say you're solving these machine learning problems, there are many constraints that often hardware designers had to deal with, which are no longer such hard constraints, right? Because traditionally hardware designers have worried a lot about the precision, double precision or the kind of precision. Often, I mean, when the data itself is noisy, you have to develop approaches in machine learning that can deal with that noise in the data. So often the precision of the data, right? You're able to work with much less precision than what traditionally hardware designers have gone for. And just like data tends to have noise and so on, you can also start to tolerate errors and so on. So as you begin to have these computations where you are able to tolerate loss of precision, tolerate errors and so on, it frees you up from being able to do much more aggressive hardware design, which can give you significantly better performance or performance per watt or performance per dollar and so on. So yes, I mean, so there have been efforts like tensor processing units. So one of the, in fact, another problem statement that my boss gave me was, yes, also start thinking about hardware software co-design for the future world, right? And see, can you guys also come up with some ideas, right, about the future, I mean, beyond the current tensor processing units and so on. So yes, I mean, there is kind of a clear opportunity to rethink hardware, and there's also an opportunity to rethink hardware and software together. Okay, so and just a final slide. I mean, there are lots of mechanisms that Google Research has for supporting collaborations. So we have a number of programs to support our collaborations with faculty, including things like Faculty Research Awards, which are given as gifts to support the research that faculty are doing. Focused awards are things where if we have something specific, because faculty research grant is usually driven more by what the faculty say they want to do. Focused award could be something where if we know that, look, this is an area that we really want to push, and where we work with some very specific faculty and get an agreement that yes, you're going to help us advance research in that area. So those are focused awards. Visiting faculty, so we do have this notion of faculty who can have a part-time appointment with Google Research. So you end up then also getting a Google badge, which allows you to essentially have access to some of the Google data, Google system, internal systems, and so on, which allows some of that collaborative work to be done at a deeper level. Then we do various workshops, and we provide cloud grants for academic research, and a number of programs also for students. We have these Google PhD fellowships. So these PhD fellowships come with actually a $50,000 grant for the duration of your PhD. So it does provide good support, right, for allowing you to travel to conferences and so on. And in addition, Google also usually then organizes, I think it's once a year that you actually go to, then all the PhD fellows from all over the world come to Google Research headquarters in Mountain View and so on, right? And there are a whole bunch of interactions. There are internships. There is this notion of AI residency, which was to help increase the pool of AI researchers, and various scholarships, travel grants. I mean, if you have a paper in one of the top conferences, need not be with any Google person. I mean, if it is in a top conference, one of the top conferences in your area, there's a good chance that we will support your travel to that conference. So we provide those travel grants and so on. So a lot of these mechanisms are available to support these collaborations. So again, I hope over a period of time, we will see a lot of collaborations between Google Research India and IIIT Bangalore. So let me stop here.